Plus Yummy Gummy through his science experiment, the model's what happens to a cell in an environment that's more watery than the cells inside. And what I saw came as no surprise. My gummy bear extended, quadrupled in weight. My gummy expanded and increased so great. So listen up as Mr. W explains this. It's all about osmosis.
Osmosis is the diffusion of water across a membrane or water permeable border, diffusing like all molecules in fluid situations from higher to lower concentrations.
Osmosis, H2O diffusing. Osmosis, see the water oozing. Hypotonic to hypertonic flow. Osmosis, let's go.
Let's talk about our gummy in osmotic terms. Hypotonic, hypertonic, isotonic are the words you can use to discuss water's watery diffusion. Learn them well to avoid confusion.
Hypotonic means higher water concentration and relatively lower solute concentration.
Hypertonic is the opposite percent of water's less, with more solute dissolved inside, as you might guess.
So let's take these terms and apply them to our gummy bear. I'm looking at the package to see what it says here. Each bear is mostly sugar with some other stuff mixed in, and holding it together is the protein gelatin.
So when you put a gummy in a cup of H2O, it's readily apparent that the gummy is so hypertonic to the water that it's in, and water's hypertonic to our little gummy friend. And so through osmosis, the water will diffuse into the gummy, which soon will look so huge, the massive gains in water which will infiltrate the gummy, which one day later is looking pretty funny.
Osmosis, H2O diffusing. Osmosis, see the water oozing. Hypotonic to hypertonic flow. Osmosis, let's go.
Next, I took this freshwater plant named as Elodia. It lives in lake and ponds and never in salty sea. In freshwater, Elodia cells are full and firm. It's all about osmosis, as we're gonna confirm.
See, the cells are hypotonic to their watery exterior, so water will diffuse into the cell's interior, expanding the membrane, pushing it against the wall. In fact, you can't see the membrane at all.
But add some salty water so the outside's hypertonic, and water leaves the hypotonic cells, it's so osmotic. Membrane leaves the wall, the cells inside are scrunched, the chloroplast cells stuck together in a bunch. That's why at the grocery store they always have the mister. The water on the veggies helps to keep them crisper. The droplets on the veggies are a hypotonic brew. Osmosis moves the water in the veggies look brand new.
Dried fruit and beef jerky presentation is osmotic. Their low water content makes the dry food hypertonic. So any germs or molds that fall upon them lose their water and die and don't contaminate the dried food any longer.
Osmosis, H2O diffusing. Osmosis, see the water oozing. Hypotonic to hypertonic flow. Osmosis, let's go.
Animal cells in situation hypertonic lose their water, shrink and shrivel. Looks so sick, but an animal cell is hypotonic. A boat gains water and expands and eventually explodes. Cause animal cells like a wall, of course, so nothing pushes back at the osmotic force. Water flows from the hypotonic to the hypertonic cell, which bursts cause the membrane can't stop the swell.
If you want to keep a frog heart outside of body beating, an isotonic fluid is what you'll be needing. Water concentration same on each side of the cell. No gain or loss of water, the cells feel so swell.
The paramecium, which lives in ponds and lakes, constantly fights osmotic water uptake. The contractile vacuoles a pumping adaptation to deal with the osmotic situation.
Osmosis, H2O diffusing. Osmosis, see the water oozing. Hypotonic to hypertonic flow. Osmosis, let's go.